Hey, what's up, guys? Yeah, so let's solve this Leetcode problem, and I think the problem is very interesting. So let me just explain. So beautiful arrangement too. So given n k, and your answer must be n different numbers from 1 to n, and need to satisfy the answer the uh, the the next neighbor, the a1 to a2, a2, a3, a3, a4, exactly k distinct integer. Return any of them. If n is 3, you can, for example, into 3, k equals to 1, you can get 1 to 3 because 1 and 1, there's only one of it. N equal 3, 2, you get 1, 3, 2 because 2 and 1. Okay. So the first idea should be brute force, right? But you get 1 to n permutation, so you get n factorial. So brute force cannot happen because your n can at most can be 10 to the 4, right? So there's no way. And so this solution can be built from scratch. Okay, so let's say the limit case. So let's say the simple case is k equals to 1, right? So this is simple. You just take 1, 2, 3, okay, 8. Okay, so there are differences 1, 1. Okay. The second is that you can take so what is the largest k, right? So largest k should be n minus 1, right? Because you at most have n number, right? And the n minus 1 difference, so n minus 1. And this is a little bit hard to think, but if you start from 1, then you should put 1 minus 1, n minus 1, and 2, n minus 2. Okay, so you get 1 and the n, and the difference. So largest difference must be sorry, this is n, and 2 and then minus 1, 3 and then minus 2. So you take these two, you take these and these and these and these, right? And you can check that their difference everything is different, right? Because this is n minus 1. If you take absolute value, this is n minus 2, this is n minus 3, this is n minus 4, this is n minus 5, right? So exactly have n minus 1. Okay. Okay, so in what we can just combine these two, and get a general k, get a general k. Okay, so let's do the mathematics. Okay, so right, so let's do this. So let's say somebody give you a general k, and the easy way is to let's say if you go to 1 to 2 to 3 up to n minus k, right? And then you can separate to n minus k plus 1 up to n minus k plus 2 up to n. Okay, so how many difference, right? So for this one is 1, 1, 1. Sorry. So in this case, you only have one number. Okay. And then for this one, I use the trick, right? I use the trick that which I can permute. So total, I have what? I have k numbers. Sorry. I let me just do this. I think this should be n minus k minus 1. Okay. And this is n minus k plus 1 up to n, right? So total I have a k plus 1 term. Okay, so I have k plus 1 term. Okay, so if I use the second case on this and the first k on this, so for this one I just fix, for this one I just permute, right? So I get n minus k, I permute it into n minus k, n and n minus k plus 1, and n minus 1, right? So you see the difference is k minus 1, k minus 2, up to 1, right? So total, this will give me the exactly distinct k numbers. Okay, it's distinct k integers. Okay, so the answer just this. The answer just this. Okay, so the answer, one of answer is 1, 2, 3 up to n minus k minus 1, and now it becomes minus k and minus k plus 1 and minus 1. Okay, so you can, somebody give you a list, then you just first start from here, 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 and then build this, and then you add, concatenate with the first 1, 2, 3 up to n minus k plus 1, right? So this is the answer. Okay, because this produce 1, this produce a k of them, and the 1 and 1 are the same, so total have k distinct integers. Okay, so once you listen my proof, you can just write down a code. Let's do this. 1 to n minus k, and so this is the first one, right? And if the even is even, then just n minus k plus I divided by 2. Otherwise, n minus I divided by 2. And this is simple. You can check by yourself. And the return answer. Okay, so this is the linear solution in n because you just build n of them. Okay, so see you guys next videos.